Hello friends, Standard 11 Chemistry, Unit 1, some basic concepts of chemistry, Part 12. Today we are going to learn limiting reagent. In this reaction, 2 mole of reactant A and 3 mole of reactant B. This will be our reactant. So react with each other and to form A2B3, that is our product. The reaction is proceed, but after some times no further reactions takes place because reactant A gets consumed and whatever be the amount of B remains. So it is said to be reactant A is limiting reagent. In short, it is called said to be in lesser amount compared to reactant B. Okay, see here, when the amount of 2 or more reagent are given, when amount of 2 or more reagent are given, then the reagent having less amount than required and is called limiting reagent, or in other words it's a reactant which is present in lesser amount gets consumed after sometimes. Here in this reaction, A in lesser amount, and therefore after no further reaction takes place. Whatever be the amount of other reactant is present, and it is said to be our excess reagent. In short, you can write here ER, and A, that is our limiting reagent LR. So whatever be the amount of reactant is present, reactant which get consumed that limit the amount of product formed. In short, it stops the chemical reaction, and therefore it is called limiting reagent. In short, we can say lesser amount of reagent is called limiting reagent. Suppose here of 5 mole of reactant A is react with 2.5 mole of reactant B, and the reaction is carried out. Here in this two reactant, which one is limiting reagent? That is in lesser amount. That's why B is called our limiting reagent. Why? 2.5 is lesser amount as compared to 5 mole. Okay, let's see another example. Suppose here 300 atoms of reactant A and 200 molecules of reactant B. So here 200 molecule of reactant B, it is said to be our limiting reagent. Because in both reaction is A plus B2 that gives AB2. This reaction is considered. Now our next topic that is stoichiometry of chemical reaction. Stoichiometry, that means this is two Greek word. Number one, stoichion, and number two, metron. Stoichion, that means element, and metron, the meaning, measure. Stoichiometry that deals with the calculation of mass of the reactant and product involved in a particular chemical reaction. So we can found here that deals with the calculation of masses of reactant and product that is involved in a chemical reaction. What type of information is available from stoichiometry? Let's see here the information like mole, molecule, volumes, then after mass and number of molecules. These all are information is available from the stoichiometry of chemical reaction. Let's see example. Here 1 mole of ethane and react with oxygen gas that gives carbon dioxide gas and water vapor. This methane and oxygen is said to be our reactant, and carbon dioxide and water vapor is said to be our product. Now number of atoms on reactant side for carbon is 1, on product side is 1. Now for hydrogen, here 4 atom of hydrogen and here 2 atom of hydrogen, so we need to multiply with 2. By multiplication of twice H2O, here the number of atom of oxygen on reactant side is 2 and here 2 plus 2, that is 4, so we need to multiply on reactant side of oxygen with 2. Now the atoms on reactant side is equal to product side also. Let's see the information. Number 1 mole, then after molecules, for CH4 here oxygen, carbon dioxide and water molecule. Here 1 mole of methane, 2 mole of oxygen, and the product side 1 mole of carbon dioxide and 2 mole of water. Then molecules available is said to be here 1 molecule of methane, then 2 molecule of oxygen, 1 molecule of carbon dioxide and 2 molecule of water vapor. Then after another information regarding volumes. Here 1 mole of gas, it is equal to 22.4 liter, means here the volume is 22.4 liter. Here 2 mole multiply by 22.4 liter is equal to 44.8 liter. Here as same as here, because carbon dioxide is 1 mole, 22.4 liter, and for water molecule here 2 multiply by 22.4 equal to 44.8 liter. Then after its mass, here for carbon 12 plus 4 of oxygen, that means 16, so 16 gram, 16.0 gram of methane. Then after for oxygen, here 2 multiply by 16 equal to 32 gram, but here 2 mole, and because of we need to multiply with 2, that is equal to 64 gram. Then after, for carbon dioxide, here 12 plus 2 atom of oxygen, that is 32 equal to 44, need to be 44 gram. And then after, for water molecule, 2 plus 16, 18 multiplied by 2, 2 multiplied by 18, that is 36 gram. So masses of this two reactant CH4 and oxygen, and the product carbon dioxide and water. Then after, number of molecules. For number of molecules, here mole multiplied by Avogadro number is the simple equation for number of, to find the number of molecule. Here the mole, that is 1, and Avogadro number 6.022 into 10 raised to 23, that is equal to 6.022 into 10 raised to 23. Here 2 mole, so we need to multiply with 2 into 6.022 into 10 raised to 23, it is equal to 12.044 into 10 raised to 23. Here 1 mole, so 1 multiplied by 6.022 into 10 raised to 23, it is equal to 6.022 into 10 raised to 23. Here 2 mole of water, that's why the number of molecules 2 multiplied by 6.022 into 10 raised to 23, it is equal to 12.044 into 10 raised to 23. Okay friends, so this all data is available from the stoichiometry of chemical reaction. Now let's see another topic, the stoichiometry of reaction in a solution. Majority of the reaction are carried out in a solution, and therefore it is important to understand is how the amount of substance is expressed when it is present in the form of solution. Let's see here, first of all, the basic concepts about what is solution, amount of substance, it is said to be solute and solvent. Let's see here. Stoichiometry of reaction in solution. This is very most important part, as well as in standard 11 and standard 12 also. So particularly for this concept, this need to be very frankly to say, please remember all the formula regarding stoichiometry of reaction in solution. First of all, let's see here, solution is made up from solute plus solvent. First of all, let's see what is solute. That means substance which is dissolved in solution. Substance which is dissolved in solution, that means it is always in small quantity. For example, here sugar or glucose or sodium chloride or Na2CO3 or NaHCO3 or KOH or NaOH, etc. These all are solute because the substance which is dissolved in solution. Let's see here the another, that is solvent. Substance in which solute is dissolved. Substance in which solute is dissolved. It is always in large quantity. For example, here water molecule, then C6H6, it is said to be benzene, ether, alcohol, etc. These all are as solvent. Okay, let's see here the examples. Sugar solution. Suppose solution is made up in water, it is said to be aqueous solution. Here sugar, suppose 1 gram of sugar is dissolved to 99 ml of water, we get sugar solution. So it is said to be our solute because this sugar is dissolved in 99 ml of water, and this water is said to be our solvent. Okay, so it is solute is always in small quantity and solvent is always in large quantity. Okay, this is the main basic concepts about solution. Solution, that is equal to solute plus solvent. Substance which is dissolved in solutions, that is solute, like sugar, glucose, sodium chloride, sodium carbonate, sodium bicarbonate, potassium hydroxide, sodium hydroxide, all are solvent. The substance in which solute is dissolved, it is always in large quantity. For example, water, benzene, ether, alcohol, etc. And the best universal solvent, that is water. Most of the solution is prepared from water. So suppose solute is dissolved in alcohol, it is said to be alcoholic solution. Okay friends, or solute is dissolved in in water, it is said to be aqueous solution. Okay, now let's see the concept, that is amount of substance present in the given volume. It is expressed in units like number 1. Please remember all these units. Number 1, that is mass percent. Number 2, volume by volume percent, that called volume by volume percent. Number 3, mass by volume percent, mass by volume percent. Number 4, normality, it is denoted by capital N. Number 5, formality, is expressed by capital F. Number 6, that is molarity. Molarity, it is expressed by capital M. And number 7, it is similar to this word, but the difference is molality. It is said to molality, and it is expressed by small m. Number 8, that is mole fraction. Mole fraction is expressed by capital X. And number 9, that is ppm, parts per million. Okay, so these all are units. Number 1, weight by weight percent. Number 2, volume by volume percent. Number 3, mass by volume percent. Number 4, normality denoted by capital N. Formality denoted by capital F. Molarity denoted by capital M. Number 7, molality denoted by small m. Number 8, mole fraction denoted by capital X. And number 9, ppm, parts per million. In this chapter we learn percentage, weight by weight, then after molarity, molality and mole fraction. Let's see here. Number 1, mass percentage or percentage by weight, W by W percentage. Here let's see, weight of substance in gram dissolved in 100 gram solution is called mass percentage. weight of substance in gram. Weight of substance in gram is dissolved in 100 gram solution is called percentage weight by weight. Is to be expressed in formula percentage weight by weight equal to weight of solute divided by weight of solution. It is in gram. And here weight of solute is also in gram. Multiply by 100. Or you can write here mass of solute divided by mass of solution. Here weight of solution, weight of solution, that is equal to weight of solute plus weight of here weight of solvent. Okay, because solution equal to solute plus solvent. That means suppose here 1 gram of glucose solution in water, and it is prepared by adding 10 gram of glucose to 90 gram of water. Total 100 gram. Here let's see, calculate the mass percent of solute. 10 gram of glucose is added to 90 gram of water. That means here our solute is 10 gram glucose C6 at 12O6, and solvent, it is water, is in 90 gram water H2O. Solute plus solvent equal to solution. In total it is 100 gram. Now the formula, because we have to calculate the mass percent of solute, percentage weight by weight, question mark, percentage weight by weight equal to weight of solute divided by weight of solution multiply by 100. Weight of solute is 10 gram divided by weight of solution. Total weight of solution is 100 gram multiply by 100. This 100 will be cancel out and our percentage will be 10%. In short, here from this data we can say, suppose here 20% weight by weight, that means 20 gram solute plus 80 gram solvent. Okay, suppose here 25% weight by weight, that means 25 gram solute plus 75 gram solvent, it is equal to 100 gram solution. Okay friends, these are the basic concepts. Now let's see another example. Here, how many gram of KOH, potassium hydroxide, will be required to prepare 500 gram solution containing 20% weight by weight KOH. See here the data. First of all, write down the data from here. Number 1, weight of solute. Here potassium hydroxide, how many gram of KOH will be required to prepare 500 gram of solution, that means here this said to be our solute KOH. It is question mark. Suppose it will be X. Then after, weight of solution is equal to 500 gram and percentage weight by weight of KOH equal to 20 from this data. Okay, now the formula, percentage weight by weight equal to weight of solute divided by weight of solution multiply by 100. Here percentage weight by weight 20, therefore weight of solute is X, weight of solution 500 multiply by 100, therefore X equal to 20 multiplied by 500 divide, cross multiplication simple, divided by 100, therefore X equal to 0 will be cancelled out from this and 20 multiplied by 5, it is 100 gram. X means 100 gram of potassium hydroxide is required to prepare 500 gram solution containing 20% weight by weight KOH. Okay friends, now our next topic, that is related to mass and molar mass. It is said to be mole. Mole equal to mass divided by molar mass. But now the word that is mole fraction is expressed by capital X. As we know about mole, it is expressed by small n equal to mass divided by molar mass. But what about fraction? Let's see the concepts about mole fraction. Mole fraction, that means ratio of the mole of any component, ratio of the mole of any component to the total number of mole of the solution. Here ratio of the moles of any component to the total number of moles of the solution. That means mole fraction of component is X equal to moles of component. Component, it is here reactant or product, divided mole of component divided by number of total moles of components in solution. Suppose substance A is dissolved in substance B. What will be the mole fraction of A? Here substance, suppose our substance A, it is dissolved in substance B. We need to calculate the mole fraction of substance A. It is expressed by XA. That means here mole of component, here the component is our X. So from this equation, number of mole of A divided by number of mole of solution. Solution, that means here the reactant A plus B. Suppose the mole of substance A, it is said to be Na. Here number of mole, it is said to be our, it is denoted by Na. Number of moles means here total number of mole component A and component B. For component A, this is expressed by Nb, so divided by Na plus Nb, mole fraction of A. Now mole fraction of B. It is expressed by X, capital X, suffix B equal to. Now from this data, number of mole for B is Nb divided by Na plus Nb. Okay, is the another formula. And one thing is, keep in mind, the sum of the mole fraction of all component, sum of the mole fraction of all component in a solution is always equal to 1. Here we have two component, suppose here, that is, and their mole fraction is Xa plus Xb equal to 1. This is very most important as well as for MCQ also. Sum of the mole fraction of all components in a solution is always equal to 1. Suppose here for Xa mole fraction, that is 2. Now what about Xb question mark? From this data we can easily calculate Xb equal to 1. Mole fraction of A is 0.2 plus mole fraction of B equal to 1. Therefore mole fraction of B equal to 1 minus 0.2. Therefore mole fraction of B is equal to 0.8. Okay, so it is said to be always sum of mole fraction of all component in a solution is always equal to 1. Okay friends, next time we will discuss the another example that is related to mole fraction, molarity, molality, etc. Thank you very much.